And now, the conclusion of Safe by Design.
So let me ask you a question, Henry. Is there any way that we can kind of see how this whole thing is going to work? And like before I start spending money on the construction of the machine and all that kind of stuff, can you show me like a working model? Maybe a virtual model?
Sure, yeah. So I'm going to talk about 3 specific things next, right? So the first one is we're going to talk about digital twin, which I think is going to be kind of in the same vein as what you're talking about.
All right.
And then I'm going to dive into device object libraries and pre-engineered safety functions as well. So what is a digital twin? You ever heard of that term?
I have heard of a digital twin.
So basically all it is a virtual version of your device, your machine. So you're going to have a completely working model or simulation of your system, and you're going to be able to interact with it, develop it, change things, connect it to a program, and test your code and stuff as well.
So the benefit there would be like before I do any welding, before I do any assembly, anything, programming maybe not, but...
Yeah, programming as well. Yeah, so yeah, the really powerful piece there is, before you spend any money on developing any hardware, any hard solutions, you can actually develop the entire machine and see what's going on.
Okay, cool.
There's a lot of things you can do when you actually visualize the system and see how things are actually interacting. You might see issues, problems that need to be resolved.
Right. Okay.
Way early on in the design cycle that you can then adjust virtually without having to, cut welds and re-weld things, right?
Assembly.
There's all kinds of issues that you run into.
sure.
Way more expensive that way, right?
Right.
So there's basically 3 pieces to your digital twin.
Okay.
The first piece is this model, right? Or excuse me, the first piece is your programming, right? So Studio 5000 Logix Designer, we've been talking about that already. So that's just your programming software, the tool that you use to develop logic that's going to actually control your machinery. So you're going to develop a functional program using Studio 5000, and you'll need that to run your machine anyway.
Okay, so we would have to write code, like some pieces of code to get that functionality to work.
You will have to. You don't necessarily have to have a fully operational.
Okay.
It's kind of depends on how you do your design. I'm more of I want to design a little piece of code and test it.
And make sure it works.
Yeah. Make sure I'm headed in the right direction kind of thing.
Okay.
So it depends on how you want to do that.
Okay.
So
all right. So I got to write code.
Yeah, you can use that approach. You don't have to technically have any code. You can create a configuration and run things manually as well. But yeah, if what you're doing essentially is trying to test your code out. So this. If you write your code, you have the ability to test your sequences and things like that and make sure your code's running properly. Okay. So that would be kind of step 1.
All right. Well, now hold on. You said that I didn't have to buy any hardware. So how am I going to be able to test my code out without having any hardware?
That's a great question. So that's where the second piece comes into play. So there's this new software tool. It's called FactoryTalk Logix Echo. And what this is a virtual PLC, a virtual PAC, whatever you want to call it. So this tool runs on your PC without any PLC hardware. You could buy your PLC, put it, hook it up to 24 volts, put it on your desktop, download a program to it, and run it that way. You could do that, or you could use a virtual version of it, and not wait for your PLC to come and not buy that hardware yet. Develop your code and then run it on Echo.
So, I heard a little bit about the RS Logix 5000 emulate program. Is it kind of like that? Or?
It's similar to that, but it's like way better.
Really?
Yes.
Really?
It's so easy to use. So,
okay.
So to use this software, you go in, you add a PLC of whatever revision you want. We're up to 36 now. Not whatever revision. You can't use version 12.
Right. So 30. I think it started 33.
33 I think
something like
that.
Out of character here. This is an awesome product. If you need an emulator, I'm not kidding. This thing is super easy to use. You can take your program as it stands, download it. You don't have to change it to the emulator processor type. It will support all the connections that you've got. So you've got PowerFlex drives, you've got servos. Talk about the servo real quick. We're just doing a quick plug because it's an awesome product.
Yeah, so kind of an understated piece of this presentation, but yeah, Echo is a really powerful tool, and it's like so easy to use. You don't think about it when you're using it, right? You just download it and it just works the way you think it. I'm going to use it in a minute to show you our digital twin working. So I'll dive into some of the features there so you can see that as well. But yeah, very, very nice product there. But yeah, it's really simple. You just add your PLC, and then once you've got that up, it'll automatically start it running, and then it'll show up in RS Links, just like another device. There's going to be another a driver that'll pop up, an emulate driver, and you'll just see it pop up on that driver, and you can target that PLC and download to it from Studio 5000, just like normal. So that's really all there is to it. It just works. It's a really nice tool. So yeah, so that's the second piece. You know, like I said, understated piece of this, but it's a really, you know, important part of having your fully functional digital twin. And then the third piece is your model. So I wanted to start with this, but I didn't, apparently. So this is, you know, I'm using Emulate 3D to show this, but you don't have to develop this model in Emulate 3D. You can use Inventor, you can use SolidWorks, any 3D machine or model development software will import into Emulate 3D, and then you can mark it up with the physics that is going to be used in Emulate 3D. What we used was Inventor. We developed this model in Inventor and then pulled it in. So I'm going to kind of walk you through a little bit of how that works. So the physics engine in Emulate 3D uses this tool called CAD as the model. It's a toolbar that has different constraints that you can add on to the machine components. And by the way, this CAD as the model toolbar is free to import. It's a separate tool that you can import into third-party CAD software packages. So Inventor has a free toolbar. So you could actually do the markup in Inventor and then import it into Emulate 3D after. So anyway, moving on. So you get a bunch of different, you know, versions of moving components and constraints. If you've done 3D modeling, you're probably familiar with the idea of, you know, moving models and interactive models. Similar thought process here, but I'm going to get into the powerful piece of Emulate 3D in just a second. So you just mark it up, standard like you do with other models. You define the way that that the physics is going to interact with the machine. So, you know, you might have a linear movement. So in this case, right, we've got our slide axis. So that would be your prismatic joint. So you're going to have a linear type movement, and then we also have a rotating brush. So that's a revolute joint. So just different physics for different, you know, purposes, basically. Setting up more simple systems. As an example, we're setting up our slide axis, right? So you just simply define the direction of travel, you know, where you're going to move, and you can define limits and things. And this is the powerful piece of it here. We're actually going to say, hey, we want to read the value of the distance of that axis from the PLC. So we're going to take information from the PLC into our model, and we're going to use that to tell us the actual position of the model. So after you've done that, you can pull up Emulate 3D's I/O browser. So this is going to look really similar to RS Links. The reason for that is because Emulate 3D is actually owned by Rockwell. So if you see it in RS Links, then you're going to see it in the Emulate 3D I/O browser. So you'll be able to pull that up in Ethernet IP. You'll see, you know, in this case, we're using our Echo instance with a downloaded program. So we're going to select that, and we'll be able to use that to communicate back and forth with the model. So what you do is you pull that PLC in, using the IO browser I just showed you, and then you can import all the tags that are in the program. They just all import in and pull into your Emulate 3D program, and then you can tie those tags to specific components. So in this case, I'll show you, we're using a distance tag. So Hayden, what would I tie my distance tag to?
Well, if it's a servo motor, wouldn't it be like current position?
Yeah, so you'll use your position information.
So it links whatever I'm basically doing in Emulate 3D, it links it with a tag inside the PLC that can give me that feedback.
Exactly, yep. So we're actually going to use the .actual position tag for the servo axis, and we'll use that to tell us where our position needs to be.
Gotcha.
We can go either direction, right? So I can take information from the model into the PLC. We can take information from the PLC into the model. Whatever makes sense for what you're doing, IO, right?
Okay.
So yeah, so that's importing whatever you have written in your code. This is why it's nice to have some code developed, so you'll actually have some stuff to tie.
Not codeless. Got it.
Yeah. So yeah, and then you just tie everything together, and you have your digital twin, basically.
Well, I would love to see this, Henry.
Yeah,
you got something put together here for us?
All right, so we have our virtual model of the machine. You guys already looked at this. You've been looking at it
right. Yep.
this entire time, right?
Yep.
So what we have here is our system. I've already marked it up with the different constraints we discussed. And you can view those if you select different components of it. You can see that I've got various things connected to it in the model. And then if I pull up my IO browser, I can see that I've got IO connected to it from my PLC program, right? So I've got my servo position tied to my distance, for instance. So that's how we're going to actually be interacting with the model. Another thing that you might notice here is I've got these
show me the photo eyes.
Sensors,
How do you interact
so
with the
you
photo
mentioned
eyes?
that you're going to have photo eyes to detect that, hey, I've placed
Parts
a plate
on the conveyor.
on the conveyor.
Yep.
I can actually create a virtual photo eye that can then detect whether the part is on the conveyor or not.
Okay.
Right? So you'll see how we interact with that as well.
Do you use the photo eye tag?
Yes.
In there?
Right. So let's pull up the PLC program that we developed so far
right.
for this. Let me make sure I got the right one, because I got two running. All right. So what we're using here is, let's go to our load PE. And you can see it's actually made right now. Go to cross-reference. So what I'm referencing for this tag is...
OT.
Oh yeah, I went to the wrong thing.
Yep, it's fine.
Might be. There we go. All right, so right here, this is the tag that I'm referencing. So this tag here is the photo eye tag that's brought in with the add-on profile when you bring the photo eye in.
Yeah,
right.
Yeah.
So over here on the left-hand side in our
there, you got it right
controller organizer, right? So we pulled in our photo eye. Obviously, I'm not communicating with that device right now because I'm all virtual. There's no I/O connected to me. But I do have an I/O tree that comes in pre-built when I create that device in my I/O list. So what I can do is I can actually write a value to that same tag, and I can use the actual tag. So we're targeting this process data in .triggered tag. And let's go just take a look really quick here. So for this photo eye, the in-feed photo eye, let me make this bigger so you can see it. So you'll see in-feed PE process data in .triggered, right? That's coming, that's being written to the PLC, right? And it's just referencing this visual property, which is my, didn't mean to resort, but I did, which is my 42 EF distance sensor, right? And basically, I have a tag in here that's saying if it's blocked, write a 1 to that tag in the PLC.
So what we're saying is instead of actually having to have physically a PE tied to something and having it go high or low or whatever, however it's set up, we can have Emulate 3D say, okay, you're blocked just simply because you've blocked the path of the photo eye.
Exactly. Yep,
Okay.
and you'll see that actually operating
So,
here in
and
just
then
a
that will
second.
drive that tag inside the PLC to move on to the next step, is what I think what you're saying,
Yep,
right?
yep.
Okay.
And it's actually gonna operate the same way that your physical device will.
Nice, okay.
When we're doing it. Another thing I've added on here is your DMS sensor that you discussed, right?
Yeah.
So you can see that's your laser sensor that's detecting the distance where your cart is. on the path.
That's our home sensor, by the way. We're using that. It's really a really overrated home sensor, right? But I mean,
So
it
I can-
works, right? It's
so
another
I can
device.
actually home to that virtually using my virtual model,
Yeah.
right?
Yep.
Okay, so I'm running my model. So I've got I've got my tags reading actual values. So I should be able to run this machine. Let's check it out. Let's see. So if I press the start button here, let's see what happens. All right, so my machine is starting to cycle. So it went through the brush. You can kind of see it's turning. It's going to my Cognex to scan the barcode, and then it goes to the next station to
See the
check the
cutouts.
cutouts. Now there are going to be certain things that you can't do.
Right.
virtually.
And how do I interface the Cognex camera and the Swift
I can't. So you're going to get like an 80% version of
Right.
your program.
Okay, fair
Right?
enough. Yeah.
You're going to be having to do some commissioning when you get your actual.
But we can treat it like the PE, like for instance, block, right?
Yeah.
So as soon
Yep.
as we block that
Yeah,
tag,
you can create.
we do the same
different
thing, both the
hooks
Cognex
into-
as well as the Swifty.
Absolutely. So yeah, so I'm just going to take the plate off of that, and you can see when I remove the plate, the photo eye gets unblocked, and then what you'll see is when a new plate comes on. I don't know if you could tell or not. I couldn't really tell from the screen, but do you see how the beam kind of turns dark? That means it's blocked, right? So when the beam turns dark, that means I'm sending a 1 to my PLC.
Gotcha.
Right? So I'm going to remove that plate, and we'll go and cycle again. So this is kind of just testing our cycle that we set up, right? So we
That's
developed code, so we're able to we're able to actually test exactly the way that we want it to run in the real world. Does that make sense?
Yeah, absolutely. That's awesome. That's a cool digital twin there. So we can make little changes in the program and see if they actually work mechanically.
Yep. Yeah, so the one piece we hadn't talked about yet that I meant to was echo. So again, it's just kind of running in the background. So it's really easy to forget it because it's just doing what it's supposed to be doing. But you can see my PLC, my Logix designer kind of looks a little bit weird. And it's because I'm targeting an echo instance, okay? So here's my path. It's a loopback address. I was able to find that, excuse me. I meant to click Who Active. I was able to target that using RS links. So we should be able to see it here. There's my Echo instance that I created. And then here's my Echo program running in the background. There's some basic information that you can see in here if I turn on the right toolbars. Here we go. You can see if it's in run mode or remote run or hard run or hard program.
You really don't have to pay a whole lot of attention to this.
There's not a lot.
Abby. There's not a lot to it.
There's not a lot
You
of
just
configuration
kinda
in here.
go.
It's just you create the PLC and it just works. Now the really cool, powerful part that
Yeah,
Hayden was
this
kind
is
of
really
alluding
cool.
to. So something that just recently became available is this thing with integrated motion.
This is really cool.
That's called a virtual, or it's not actually a virtual axis. It's called test mode. If I can find the daggum thing. You see the little blue arrow there? These axes are in test mode. So I didn't have to do anything to enable test mode. They were just enabled by default, which is one of the reasons I can't readily remember where the configuration is because it just works. When I downloaded it to Echo, it just put it in test mode. And what test mode is, this axis is fully configured. So this is actually a virtual axis. So this is what you used to use in the past. If you had Emulate 5000, you would use a virtual axis and you couldn't actually have real configured axis of motion. You'd have to do that after the fact. So this is a virtual axis, so that's kind of familiar. But this axis is actually tied to our actual drive. So you can see it's connected to our Kinetics 5500. It's already configured. Now it's not talking to anybody in the real world. It's being virtually simulated by this test mode feature, okay? That's what Echo's using to run the motion.
You could never do that in the old emulator packages. Never, not in a million years, right?
And just so you know, this is actually not a feature of Echo. This is Studio 5000.
That's right. Yeah.
So you can do test mode with a PLC on your desktop if you wanted to. Just aside. But totally virtual. Again, like Hayden said, I've got a PLC program that I can now, all I have to do is download it to my actual system and it will work the same way. Does that make sense? There's no configuration changes or anything like that you have to make. There used to be a lot of massaging that you had to do.
Yes, most definitely.
So it's a lot nicer now. So anyway, that was the last little feature of Echo. But yeah, Echo is it just kind of works. All right, so the next thing I want to show you is these two powerful resources that Rockwell provides that we think are going to help you a lot in terms of getting the most out of your system. So you, Hayden, you walked through with Michael selecting a bunch of these smart devices, smart components.
Yep.
And you he said that there's a lot that you can get out of these, a lot of like visibility, diagnostics,
lots of extra,
that kind of thing.
yeah.
So what I want to show you is one way that you can get access to all that information.
Okay, cool.
So with device object libraries, have you ever heard of device object
I have
libraries?
not heard of device object libraries.
So what these are pre-canned code packages that you can use. They're pre-configured, pre-built code and also visualization tools that you can just utilize for free from Rockwell that interact with devices.
You gotta have a login.
Yeah, you always have to have the login. They just want to know who it is.
Just want to make sure.
They want to know who you are.
Right, exactly.
And so they can send you marketing emails. What you do is you go to the Product Configuration and Download Center, PCDC.
Gotcha.
It's really easy to get to now. It used to kind of be hidden.
Right there on the main page.
But
yeah. Okay.
So yeah, it's really easy to get to now. So you go to the PCDC and you can have access to all this. All of these things together are called the device object libraries. So there's a bunch of stuff going on, right? There's a lot of different components, a lot of different pieces. Power devices, I/O link, I/O cards, even safety device libraries. There's all kinds of stuff in here to be able to utilize and get that information out of.
So it's just you got it.
So I'm gonna walk you through a little bit about again high level of how this works. So what you get with each library, with each object, is you get an AOI that you pull into your PLC program. So you import the AOI and then you can instantiate it in your code for each device that you're using.
What does AOI stand for?
AOI is add-on instruction.
Add-on instruction. Okay.
So it's an add-on instruction.
What's an add-on instruction?
It's
just asking, Henry.
It's a code block that you don't have to write.
Okay.
You just configure it.
Configure it. Go in.
You got to tie some things to
All
it, right? But it's basically a pre-written code block that has a lot of structure and capability that you can then utilize with faceplates.
That's not going to write my code for me, right?
It will not write your code. You still have to do the functional coding
to make the machine run.
Yeah, right. But what this does is it gives you that visibility, that diagnostics that nobody uses.
Gotcha.
Have you ever opened up an access tag?
Yes.
And seen how many zillions of tags there are?
Zillions of tags.
And
like,
nobody
what do I
uses
need
them
this
all?
for? What is this? Yes.
What are you using those for?
Yeah, exactly.
This is where the power of that can add.
So somebody made sense of all those tags.
That's right. Somebody made sense of most of the tags, a lot of the tags. So somebody made sense of some of the tags and are showing you the ones that make the most sense to show you, right?
Right.
So there's a lot of diagnostic information that most people weren't using. They were just doing the bare minimum functional stuff. You can still do that. You can still focus on the bare minimum functional, but get a lot of that diagnostics for free with using these device object libraries.
Okay.
So along with the faceplate, these the AOI and the faceplate tie together. They have hooks that tie together with different
backing
tags.
tag. Yep.
And these just have diagnostic and feedback information, sometimes control. Like in this case, we're showing the ability to jog manually,
Nice.
a motor. And we can see different various things, again, without any additional coding from you.
Interesting.
A lot of functionality for very little effort. Like we said, diagnostic. So wouldn't you like to know if your drive faults out, wouldn't you like to, first of all, know that it faulted?
Error code 376 does nothing for me,
And
Henry.
second of all, know what the fault is, right?
Exactly.
Well, how many times is the machine, you press the start button and it's just not running?
And you have no clue.
Why isn't it running? I don't know. Well, at least for this, you can have this pop up automatically to tell you that it's faulted and why, right?
Okay.
So a lot of power there. The second thing I want to talk to you about, you and Kevin talked about different safety components.
Yeah.
Not all of them. A specific set of safety components.
Light curtain.
A light curtain. Right. So what I want to talk to you about with that is pre-engineered safety functions.
Okay.
Rockwell's pre-engineered safety functions. So we have a way for you to integrate that safety function into your system without having to go through as much effort to figuring out how to design and tie it into your system. Okay. So I'm going to tell you about these documents. So these are technical documents, white papers. Rockwell calls them application techniques that will explain to you the proper usage of different components in a specific way, right? So you're going to get wiring diagrams, bills of material, programming in cases where programming makes sense to show you. This can be found on Rockwell's www.machinesafetysolutions.com.
So let's just say if I went and we decide to use those light curtains that we were talking about, and we're going to use the drives like we basically came up with in the risk assessment, right?
Mm-hmm.
I mean, so what you're telling me is there's a place I can go on the Rockwell website to say, okay, I want a light curtain functionality and I want a servo drive and a 527, and it's going to have this for me?
Almost. Yeah.
Almost.
So what you're going to get is you're going to get an example of how to use specific devices in specific ways, and you kind of have to do a little bit of a mix and match.
Fair enough.
So you got to say, hey, I'm using this light curtain. I found an example of how I'm using this how they're using this light curtain with maybe they're using it with a 525.
Right. Yeah. Exactly.
Right?
Or 755. Whatever.
We've got a 527, so it's a little bit different.
But you would find maybe the 527 or the 525 or the 527
then you can find an
side of
example
it
that has a
and then move them
527
together.
and figure out how they mesh.
And it's going to have all of this for me.
And you get a lot of examples of how to use that and how to configure it, right? So I'm going to show you a little bit. So this is kind of an example one. I'll walk you through this in a little bit. I'll pull this up so you can see it more clearly how this works. But it'll tell you, what performance level you're going to get. I don't know if you guys can see that. Probably not. It's really tiny. But it says Category 3, Performance Level D. So if you follow the procedure and the recommendations on this document, then your safety function is going to meet that level, right? And it's not just that. There's more to it, and I'll get into that. But on the base level, that's what you get. And in this case, they're saying, hey, you can use control logics or a compact logics. I don't care which one you use. This function will work with either or. So sometimes you'll get that, right?
Mm-hmm. Yeah.
Some back and forth. But this is just a simple e-stop example, right, with a safety output and dual.
Yeah, you can see the input, the control device, and then the output with being the safety contactors. Right?
Does this look familiar to what you guys were talking about with SAB? With the
absolutely,
input, logic, output?
It models that perfectly. Yeah, that makes sense. Yeah.
So you'll get wiring diagrams. How do these different components tie together, right? So most of the time you pull up a manual for a safety device, and I got to look at that specific device, how it wants to interact with other things. Sometimes that can be confusing and time consuming to figure out how I wire in other parts,
Very
right?
much so.
Where do those pieces come in?
Yeah.
This shows you a systematic approach, an application approach.
So it really takes a lot of the guesswork out.
Yeah.
And I'm assuming liability too then, right? some extent.
Yeah, I mean, you're still
You're still responsible
you're
for it,
still
but you're not.
responsible in the
Yeah,
end.
no, I
but
get
they're
it.
helping you get to that documentation that Kevin
Okay.
and you guys talked about,
All right.
And I'll address that.
Code.
So the other thing you get, you and Kevin specified a Ethernet safety light curtain
Yeah.
and Ethernet safety drives, right?
Yep.
So guess what? There's no wiring with that.
I don't sell IO modules that way though, Henry. I don't like that.
There's
Anyway.
no wiring. So you're just going to use safety code
Wow.
to develop the safety for that for your system, right? So you're going to get examples of how to properly implement your safety function in your code.
That's pretty amazing.
Right? So you don't even have to think through that.
Right.
That's one that people get worried about. Am I doing the safety code in the right way? Because there's
Yeah.
there's
Oh,
more
for
than
sure.
one way to skin a cat,
For
right?
sure.
And everyone
Some
codes
people
different.
confuse the functionality programming
Yep.
with the safety programming,
Yep.
and
Everyone codes different.
Yep.
Well, if you follow this procedure, then you don't have to worry about that piece of it. Safety code should be simple. It's meant to be as simple and clear as possible, right? So it's just easier if you follow an example of procedure that's already given to you. So that's provided for you as well. So another thing that you're going to get along with this document is attached to this document, you're going to get a list of files. Did you know you could attach files
What?
to a PDF?
No, I had no idea.
You can attach files to a PDF.
Is that why those PDFs are 120 meg?
They're huge. They're huge files, these PDFs. So what you'll do is you'll actually need to download the PDF. Actually,
You're going to show us this, aren't you?
I recently discovered that sometimes in the browser you can see the attachments, which is cool. You didn't used to be able to do that. But you click on the little paperclip icon and it'll pull up these files that you can see. So like I said, you'll get drawings that you can literally copy and paste into your electrical drawings. There's one for AutoCAD, ePlan, ACD files. You know what an ACD file is?
I
Hayden?
think that's the Logix 5000 programming
I'm just
software.
testing your knowledge, that's
Okay,
all.
sorry.
Yes, that's.
You don't know.
Yeah,
I don't know any of this.
You've
What
never
is
heard
this?
of that, right? So ACD files. Remember you talked about Sistema with Kevin?
Yeah.
Here's a Sistema example file for this particular application technique, right?
Okay. But let me ask you though. If I've done the safety automation builder and did the Sistema, got the Sistema report, what does this do for me?
Yeah, so what this will, as I said, you're not always going to get the exact match. Sometimes you do.
Right.
Sometimes
right,
it's exactly
for sure.
what I want. But what this will allow you to do is kind of do a comparison and make sure that what you developed in SAB matches what Rockwell developed and make sure things
That'd be
jive
like
and make
it's
sense.
just like another check.
Yeah,
It's like another
another
set of
check.
hands looking at it. Okay.
When we're talking about checking things, validating things,
Right.
that's another thing that I kind of skipped over in a minute ago is they provide you with this validation checklist so that you can go through and actually go through a sequence of steps to validate that you've set up your system and designed your system properly. So once you get everything
Nice.
up and running, you can actually go through this validation checklist. That is what's going to allow you to say, yes, I'm meeting the performance level that I would like to meet, right? So just in case you forgot, MachineSafetySolutions.com is how you can see it. I'm not going to go through the whole thing, but as I said, this is that example that I showed you guys a little bit ago. But you see, what performance level we're going to meet, and they give you a procedure to walk through and what devices to use. Again, wiring diagrams, code if it makes sense to have code for the application. Here's that little paperclip icon I was telling you about. So in this case, you get a bunch of different files. I'll just pull up this validation checklist so we can see what it looks like. Hopefully it doesn't download a virus. It was like saying it was mad. All right, so just as an example.
Yeah, so show me part of the validation here as far as if I'm going to test this out, make sure my safety works.
So yeah, like how would you walk through this step by step?
So it looks like...
Does this make sense to you?
Yeah, so I don't know if you guys can see it, but the first test step is initiate a start command. Both contactors energized for a normal machine run cycle. Okay, that makes sense. I'm just turning the machine on. Verify proper machine status indication, application program indication.
So it's pretty straightforward.
It's
I mean,
really
it just tells
straightforward.
you what to
Initiate
do.
a stop.
So you walk through it, you check the box.
Yeah, normal stop versus e-stop. So it's got both of those. So that's pretty cool. And then you just pass fail.
Yep.
And if you made any modification, wow, okay. So that's going to suffice then.
Again, this is that documentation that Kevin and you guys talked about, right?
Okay, yeah.
It's critical to have documentation that I did my due diligence
Right.
when I was setting up my machine, right?
Yeah.
So they're providing this for you so that you can do that.
Interesting. Okay, that looks like it's a huge help. It takes the guesswork out of basically me having to write that list myself.
That's right. So yeah, that's it. So those are the three things that I kind of wanted to cover. Again, when you go through this approach, you end up with a really robust solution at the end. And all of this kind of hinges on using the right tools at the beginning, selecting the right components at the beginning, so that you're getting at the end this unified package that's robust and reliable. So now, you want to like actually make the machine now?
I think we should make the machine.
Develop a machine. Let's go ahead and.
All right, so the
unveil
big
this
reveal.
sucker.
Here we go. Here we go. You're gonna need drama.
What you've been waiting on.
Sorry. Ta-da!
So here's the machine. It's mad at us right now. We're gonna fix that. But basically, Hayden, this is everything you've been talking
Wow!
about. And
Amazing.
This is everything we've been developing. So this should have all the components. It also has some extra stuff we didn't talk about because we weren't able to.
Looks like it's got a lot of extra stuff.
We weren't able to do the full risk assessment because
Right.
that would take like 2 days maybe. But yeah, so this is the machine.
Wow. So are we going to get to demo it and actually run?
It
through
doesn't
some
actually
of it?
work. It's just
Just
a big
okay.
paper.
Gotcha.
No, it
Okay.
does work. Yeah, we'll be able to do a
So
machine.
are you going to do that, or is there going to be somebody else who's going to come in and do
So
that?
I think that what we're going to do is bring in our machine specialist to help walk you through the operation of your machine.
I'd love to see that. I would love to see that. Who is that?
His name is Robbie Brown.
Robbie Brown, and he is just another guy out there who
just
knows
another
how to
guy.
run a machine. Awesome. Mr. Brown, what do you got for me here?
So yeah, if you recall, we started with our weight scale here.
Right?
And,
So what's that look like? Where is
Yeah,
that?
essentially, we've got our Mettler-Toledo scale here.
Okay.
And if you remember from the sequence of operations, that was a manual process.
Okay.
So what we're going to do, we're going to have our operator come over to our HMI. And we're going to press this weight check enable button.
Gotcha.
Load the part on the scale. Load the part on the scale.
Oh,
We're being
nice.
prompted, right? By
Okay.
our recordable stack
It's
light.
being weighed. Part is being weighed.
Wow.
Right.
The part failed the weight test.
Ah, there you go.
Okay.
You just
So
saved
you
the
see
customer,
here-
Robbie.
Yep.
That's awesome.
So we've got a
Part
fail.
from the scale.
And actually, if you guys can see here, we're missing our barcode. So that's how sensitive that this scale is. So that's actually really awesome. That's going to prevent you from actually setting a part on here that's not going to pass
Right.
any of these
Right.
subsequent
That's fantastic.
stations. So what we'll do now, also we've got this indicator here on our stack light as well that's flashing yellow. We've actually got this information here that you can print out at multiple zones, right? This could be laminated and put throughout, the zones of the, different stations on the machine. And we have highlighted here, for example, that yellow flashing means it's waiting on operator input. So this, again, is a visual indication that our operator needs to take some sort of action.
Right.
to make
Okay.
sure
that
this
makes
will
sense.
work.
Sure.
So-
Hey, get up off your butt and do something.
Right,
Yeah,
exactly.
I get it.
And again, if you guys wanted to program a specific message, we're not going to tell you what you can and can't put, but you could get graphic if you wanted. So again, we've got our correct part now. What we'll do, operator will come over again. We'll initiate this weight check enable.
Load the part
We'll be prompted
on the
again.
scale.
Now, Robbie,
Load
we
the
could
part on the scale.
just have that work, and we don't have to start it every time from the HMI, right?
That is correct.
Okay. Cool.
The weight check is good. Move it to
So
the
we're
trolley.
prompted now to move it
The weight check is
from the
good.
scale to our
Move it to
trolley.
the trolley.
We'll make sure manually that it's on there correctly. Okay, so you
All right,
can see
so
now, as
now
we're
it's
running
cleaning the
through our
brush.
automatic
Yep,
brush, we're
yep.
moving to our vision. where
That's
we're
the
inspecting
Cognex
our
camera.
barcode.
There you go.
Our 3D configurable scanner, which
Remove the part from
makes
the
sure that
trolley.
verifies that we have the cutouts in place. And then we've now gone to our unload station. And because we've passed everything, our operator will now take this out and put it in our good part category. Ready to be
Nice.
packed up and boxed.
That looks fantastic.
Yep, so that's great. And just to give you an example, you can see here, I was in the yellow or the orange. With these different zones, we've actually got different programmable settings that we can do. So you saw there as it got out of the orange zone, it moved to green and it actually moved at our fully operational speed. When it's in our yellow or our warning zone, we've actually got it programmed to operate at a safe speed, predetermined speed set by us in our program. And then again, when it's red, we'll prohibit this machine from operating just to prevent any kind of malfunctions or any operator harm.
Awesome.
Yep. So that's really cool. So we've seen a little bit about how this works. I kind of want to dive now into some of the components on this machine. And again, this is part of our intelligent implementation. So first, we talked a little bit about this safety scanner and the 3 different zones. So there are actually up to 8 different programmable zones that you guys can have on this safety scanner. So that's great.
So is that like a separate piece of software that I got to have or to do the configuration, or like that's right in
It'll be right there in
Studio 5000?
Yep.
Oh,
Yep.
okay.
Exactly.
All right. Nice. Okay.
Yeah, so as we move on, we've got our GuardLink series here, which right now, currently what we've got is our e-stop.
This guy
If you want to show some operational. So not sure if you guys are familiar with GuardLink at all, but the way that this operates, you'll have your end device and it will come to your tap here, which will then be ran to your GuardLink module here. So what's cool about this is you can have distances from up to 100 meters between devices, and then you can have 10 meters from your tap to your end device for an overall total distance per trunk line or branch of
Nice.
3,100 and I
Wow.
believe 30 meters.
So how many so this is a tap, and for each device I have to have a tap, right?
That's correct.
Right, and it goes back to there. Now how many, then you got 3 channels on here.
Yep, there's 3 trunk
so
lines.
three trunk lines.
Yep.
Now how many taps can I hang off of each trunk line?
So each trunk line can support up to 32 taps and devices.
32.
So for a
I could
total
put
of 96 devices.
Wow.
per
So-
module.
So like if this machine got a whole lot bigger and I had e-stops all throughout the line,
Right.
I wouldn't need to like run any wires to know what e-stop was pushed or anything, right?
That's
Because it
correct.
would tell me.
That's correct. Traditionally, the way that these were run, safety circuits are run in series. And the way for you to get diagnostic information would be to run auxiliary contacts to input cards on the PLC.
That's really cool.
So what GuardLink does is eliminate the need for those input cards and will give you that diagnostic information without the additional I/O requirements.
Nice, nice.
So as we move on, we want to talk about the 450L series light curtains. If you remember, this is kind of what we built our safety, our risk assessment on in SAB. And again, this just prohibits the user from the entanglement or the crushing of the conveyor or the brush as well there. And then again, we are using the SIP safety over Ethernet, which is our module here, which is great because again, it eliminates our need for I/O requirement. So we've got a transmit and receive ports, as well as links to where we can daisy chain these to additional safety curtains as well, so we can link everything together.
So most of the I/O blocks, adapters, things like stepping out of character here, have basically an Ethernet in and an Ethernet out. That means that it can support the linear topology. So if I just want to do daisy chain, and then it also supports DLR, device level ring, right? So device level ring is fault tolerant in the fact that I can lose a segment of that ring and still continue to function. But each of those have that, as well as, for instance, like with the GuardLink, we've got power in and power out. Notice that also, and this is like the star of the show too, because he is what's talking to this, that is the IO Link Master, the brand new one, right? So we've got power in and out of there, Ethernet in and out of there. You can see in the I/O tree that you've got that too. So sorry, Robbie.
You're good.
Go ahead. Sorry.
Well, it seems like you know a lot about this.
All of a sudden, no, I'm excited. I'm stoked about it. It's all really cool stuff.
Yeah, so as we move on to a couple of the Ethernet devices, we've talked about the PowerFlex 527 a little bit. Hayden kind of jumped the gun earlier,
Sorry,
but
man.
again,
Stole your thunder.
we'll bring that back up. There is a reason that we use the 527, and again, that was for the SIP safety over Ethernet. So again, like Hayden brought up, all of this information is over one Ethernet cable now, right? So we're not having to run inputs and outputs and things like that. And again, we did want to point out the 527 is our integrated motion, but as we've talked about the device libraries, there are add-on instructions that allow you to kind of control this as you would a standard PowerFlex 525 drive. And again, we've got the embedded dual port Ethernet for device level ring network topology. So if you were to lose one segment, as Hayden talked about, you'll still be covered and able to communicate and hopefully operate to eliminate that downtime. As we move on, again, similar situation with the Kinetix 5500. Again, device level ring for those dual ports, SIP safety over Ethernet again, so similar functions to the 527. And again, like Henry pointed out earlier, the main reason for using one over the other would be price and just the type of motor that you're trying to control. I'm not sure if you guys are familiar with automatic device control. It's kind of inherent to these drives up here, but it does work well on our PowerFlex 525 series as well as some other devices. Wanted to run through kind of how this works, just to give you an idea. You know, get this machine up and running, and then there will be times when, you know, during normal operation, something goes wrong, drive fails, sensor fails, whatever. In this example, we're going to go through this animation here with a drive that's going to fail. And essentially what's going to happen, you know, for whatever reason, we'll say lightning strikes, we've got a voltage spike, whatever, we lose our drive, right? So our maintenance department will come in, we're going to take our PowerFlex 750 series drive out, we'll put this new one in, we've got it wired up for power. As you can see here, we've got our controller, we've got our switch here, which is like our Stratix 5800 managed switch, and then we've got our drives itself, right, the actual end device. So there's three actual parts of this ADC. So the first is going to be that our Stratix 5800 using DHCP per port is going to assign an IP address to our drive, right? So that's going to be our first step. So as soon as we plug in our Ethernet cable, you know, hopefully our maintenance department plugs the right cable in. But yeah, we're going to get that IP address assigned, right? So from there, we're going to have what's called a firmware supervisor. And that's actually saved in an SD card as the non-volatile memory section on our PLC. We'll save that program file. And what that's going to do is that's going to flash our firmware based on our settings and our controller properties. So we can choose to enable that or disable it in our controller properties. But if we choose exact match, that will flash up or down depending on the program that's saved on that SD card. So once we've got our IP address, once we've got our firmware match, the third is going to be our configuration. And again, that's saved on that SD card. So all those parameters that are stored are going to automatically be dumped into our end device. So essentially, this is a seamless, you know, plug and play type application. As soon as we've got power and as soon as we've got our Ethernet plugged back in, we should be up and ready to go within, you know, 5 to 10 minutes.
It does it kind of on the fly.
Yep, exactly.
Robbie, I got a question for you. So if I have this happen, I know that when I've flashed a drive, or excuse me, when my maintenance staff or engineering staff has flashed a drive or a PLC, it can take some time.
Right.
Minutes, right?
Yep.
So if this process is occurring, how do I know, like for instance, the maintenance guys wired this up, we powered it, how do I know all this is going on?
So from a maintenance user's perspective, you'll see throughout this process, you'll see a couple different power cycles on the drive. One, when your IP address is being set, this will power cycle for those settings to take place. Then again, it will happen when your firmware is flashed. But you'll also be able to see this on the HMI because your controller will be able to show you at which point in the process it is and exactly where it is in that step. So it's going to be a visual indicator on the HMI as well. So it will show you where and when in that process it is.
Have you guys ever used, stepping out of character, have you guys ever used the module status tag? So when you've got any kind of device that's in your I/O tree, you'll know if the processor's actually talking to it other than the caution sign that's actually on that device, right? So there's a module status tag and you can monitor that. The magic number 9 is the value that it will be if it is flashing the processor, or excuse me, flashing the drive or the device or whatever it will actually end up being. But think about the power of that as far as that's not you with a laptop out there going and using Control Flash, Abby Lee, or Control Flash Plus. That is the processor, that's the PLC that's actually doing the flashing, changing the firmware of the device to what it should be.
Cool. Okay. Yep. So as we move on, we talked a little bit about automatic diagnostics today. So we'll dive into that a little bit. And essentially what this is any device that's connected to your logic controllers, right? You're going to automatically see this pop up on your HMI if there's any fault indications, fault conditions, sorry. This will automatically be sent to your HMI, and there's actually a little health indicator. We'll blow that up later in a slide or two. But you'll be able to see exactly what's going on. It will give you the fault information as well. So it is important to show that it does not require any additional programming as long as you're using the predefined or configured screens. Yeah, predefined, yeah. Divine. I was going to let it ride, but you called me out. That's okay. Yeah, predefined, yeah. But yeah, so we did just want to make sure that we covered that. No additional programming. So again, it's it's all been done for you. So that's really convenient. Just wanted to show you. You'll pull these controller properties up, and you'll go to the Advanced tab, and then you'll see right down there. I don't know if this button will work, but enable automatic diagnostics. So it's as simple as enable it, and you should be good to go. There is one caveat. I wasn't sure if you were going to ask or not. But some devices will have a secondary location where you'll pull up the device properties and have to enable it there as well. So just make sure if you've activated it and you're not seeing that diagnostics, then you'll just want to check that device properties tag as well.
Do we want to show them?
Yep. So from there, we'll run through a quick little demonstration just to show you, for example, hey, our operator comes out, they've opened the door or something and they've disconnected. Oh, okay.
Here we go.
Yeah, so they've disconnected, a cable, or we've nicked a line or something, we've lost power, right? So essentially what's going to happen, we'll simulate that device is lost.
So the automatic diagnostics indicator on the PanelView 5000 is this little heart, right?
Yep.
Makes sense.
Little heart with the monitor.
Distinguishing from the actual alarm, right?
Okay, let's go. There we go. And so you'll see there that little badge that popped up with a 1, right? And so what we've named this our in-feed photoelectric sensor. So you'll see in-feed, PE, and then connection loss with device.
0 programming,
right.
A checkbox.
Yep. So that's really cool. This isn't the only thing, but again, you'll see once we plug it back in and communication is established, bam, goes away. So here what we've done, Hayden, we've disconnected our trunk line, right, for our guard link, and you'll see here that we've got our channel 0 has an unverified device, right? So we've got the issue with the guard link, and then it's also showing us that we've got a PLC e-stop, right? So because our safety circuit is not complete, then it's going to prevent us from operating. So again, 0 programming, it shows you exactly where to look, which is great. Ooh, if I can get this back in. And then again, once that circuit is complete, we'll go back to normal operating conditions.
So one of the other things real quick on this is when Robbie first did the photo eye, how is the photo eye connected to the PLC? I know you guys don't. I/O link. So it not only does things on Ethernet, but it does it on I/O link too, right? Especially with this new block. It's not going to do this with the older 1732 block, but it will do it with the new one because those devices are actually listed in the I/O tree of the, of the processor, what it's connected to. So that's kind of a cool feature too. You get that for Ethernet, you get that for I/O link devices.
Moving on a little bit, we talked about like the HMI, the library, object libraries. Henry talked about that a little bit. So got your add-on profiles, add-on instructions, your faceplates, right? So those are level 4 displays, provide the most detail for your subsystems. Your operators will be able to use that without a whole lot of clutter and distractions, right? And then we just talk about, we'll run through some of the graphic symbols that you'll see. So generally includes the button used to navigate the screens and things like that. So we'll run through the anatomy. So you'll see a couple different screens down here, and then up top you'll have your home, trending, configuration, and fault screens. You'll see different types of, you've got symbols for phase, angle, port details. That's a good one down there at the bottom left is your locate, so you can figure out what, that's more diagnostics to figure out which sensor or device has failed.
So how does that work? Do I just hit the locate button and what happens?
Yep, and in the case of these sensors, it will actually flash and let you know which one is.
So it'll start flashing.
Yep.
To let me know
Actually, it's
that
programmable,
one.
right? So you can change what it does. Is that correct, Michael? You can,
I think-
you
yeah,
can
it's
hit locate
it'll just
and
do a
select
flash.
what the device will do to notify you that that's the one that has the problem. And then again, up here, top right is just your health indicator, which is your automatic diagnostics, which will show you any of the unsuppressed faults. And again, here's an example of your home tab, which will, shows you some of this information. We're not going to get too big into this because Henry's going to do a quick demonstration on the television. But again, we wanted to show the fault warning screen. You do have up to 4 faults at one time. It will show you the time, the severity, and then it will actually bold it if it's a current fault or active fault, and then it will give you up to the past 4 previous faults. So latest fault is first in the row. It says active is bold. And again, all this information, the description is there. No programming necessary. So again, like Hayden and Henry talked about earlier, you don't walk over to the faceplate and see FO37 and have to pull out a manual and figure out what's going on, right? It will tell you what the fault is and then give you an idea of where to start troubleshooting as well. So again, just one of those benefits. And again, one thing we like to hit is that this is open source, so you don't need, if you don't have a need or a requirement for all this information, you can pick and choose and build your own if that's something you want to do. But again, the selling point for this is really just that ease of implementation and then the lack of time spent programming. So very flexible.